picking up on our discussion from yesterday on finding all the zeros of a polynomial. When you don't have a way to be able to factor something, you have to look at your calculator and find out some of the real zeros. So we're going to graph the first equation. And we are looking for real zeros. Remember that we only want the rational ones. So I know that it's difficult to see from here, but there's actually 2 zeros happening. If I were to zoom in on this, I could see closer that it actually does dip below the line and there are 2 zeros happening. Now here's a quick tip. You can take a look at the table and find any of the zeros that are integers, positive and negative whole numbers. So I know off the bat that there is -1 as a zero. I just need to find what is this other zero here. The second calc option 2 can help me out with that. Left side, right side, and I get that the other zero is at -1.5. We only care about that zero as a fraction. So we're going to quit out of there and change -1.5 back to a fraction. Math frac. So I have -3/2. We know from the fundamental theorem of algebra that there should be 4 total roots. We were only able to see 2 real ones. That means that we need to be able to find the 2 imaginary ones. My first step to get there is I'm going to complete synthetic division with the 1 integer root that I was given. So I have 2, 11, 26, 29, and 12. Remember, with synthetic division, I need to multiply and then add. So multiply -1 times 2, add, and I get 9. Multiply, and then add, then multiply, add, and multiply one more time. Remember, if you get something other than 0, you've done it wrong. Now, since my other 0 is actually not a whole number or a negative whole number, an integer, I have to use Polydoku, which means I have to change this back to factor form. I was given this. I was given that x equals -3/2. So I'm going to multiply by 2 on both sides, and then add my 3. Your goal is to get rid of the fraction first, and then move everything onto the same side. So 2x plus 3 is my factored form. And now I can use Polydoku with my depressed polynomial. You have to make it back into a polynomial. So it started with a degree of 4. 1 less would be 3. So I have 2x plus 3 .
2x times what is 2x to the third? X squared times 3 is 3x squared. 3x plus what is 9x squared? 2x times what is 6x squared? 3x times 3 is 9x. 9x plus what is 17x? 2x times what is 8x? 4 times 3. And I don't have a remainder. The depressed polynomial that I'm left with is now something that I can work with. I know it looks like it's able to be factored, but you can't factor that. If you were able to factor it, you would have already had the other two zeros from your calculator. Since the calculator only gave you 2 zeros, that means that you have to be able to use quadratic formula for this. So I have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Figure the discriminant first. So that's the 3 squared minus 4 times 1 times 4 first. So 3 squared is 9 minus 16 gives me negative 7. So I have negative 3 plus or minus the square root of negative 7 over 2. We know that that negative comes out of the radical as I. So I'm left with negative 3 plus or minus I square roots of 7 all over 2. That completes all 4 roots that I was looking for. I have 2 real rational roots, and this represents 2. It's 2 imaginary roots. Let's take a look at C. It's not able to use, we're not able to use factoring to find any of the roots, so we're going to take a look at our calculator. I got to get back to a nice normal window. So I can see that there are 3 real roots. Let's find out what they are. None of them seem like they cross at nice pretty places. So I have to do second calc, option 2. Left side, right side. Now this number does not look like a nice number. This number is in fact irrational. If you were to type it into your calculator and try and change it back to a fraction, it wouldn't be able to, because it's an irrational number. So this is not one that I can include to be able to use PolyDoku or synthetic on it. So let's find another one. Left side, right side. Same thing. Irrational number. I can't use PolyDoku on it. I can't use synthetic on it. So let's try one more. Left side, right side. That looks like a number that I can make into a fraction. A repeated decimal is a rational number. And if you're not sure what that is as a fraction, you just type it into your calculator and fill a row with that number, and it will change it back to the fraction for you. So math, enter twice, it's 5/3. So out of all of those zeros that I saw, only one was set up that I could use. That means that I'm only going to have one real rational root. The other two roots that you saw are irrational roots. Since this is a fraction, I have to take a look at Polydoku. So I've got to first change this back to a factored form. So that means I have to multiply by the denominator to get rid of the fraction, and then subtract the 5 so that my factored form can be used for Polydoku. So 3x times what is 3x cubed? X squared. X squared times negative 5 is negative 5x squared. Negative 5x squared plus what is negative 2x squared? 3x times what is 3x squared? X times negative 5, negative 5x. Negative 5x plus what is negative 8x? And then 3x times what is negative 3x? Negative 1 times negative 5 is 5. So there's no remainder, which is what we needed. We knew it was a factor. So we're going to toss this into quadratic formula now. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have 1 squared, which is 1 plus 4, which gives me 5. So I have negative 1 plus or minus the square root of 5 all over 2. The 5 is prime, so I can't break it down. I didn't have any negative numbers that I needed to deal with. So I have one real rational root and two real irrational roots. For part D, we need to type it into our calculator so we can actually get some guidance as to what my real rational zeros are. So I see only one real root. It doesn't cross at a nice place, so I need to actually use the zero function. Left side, right side. And I have negative 0.5, which we know that to be negative 1/2 as its fraction. So I need to change it back to factored form and use Polydoku. Multiply by 2 on both sides. Add 1 to both sides. And this is the factored form. So I have 2x plus 1. Eight x cubed. So I have 2x times what is 8x cubed? 4x squared. 4x squared times 1 is 4x squared. 4x squared plus what is 14x squared? 10x squared. 2x times what is 10x squared? 5x. 5x times 1 is 5x. 5x plus what is 11x? 6x. 2x times what is 6x? It's 3. 3 times 1 is 3. So no remainder, that's what I needed. And then I'm using the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So I have 5 squared minus 4 times 3 gives me negative 23. So I have negative 5 plus or minus the square root of negative 23. So we know I comes out, 23 stays in. And since it's prime, I know I can't factor it down anymore. And I know I can't reduce. I'm going to go ahead and finish up the last notes problem that we started yesterday. I kind of got you started on it. We were given 2 factors. One of them was real. One of them was imaginary. Our complex conjugate theorem says that there's always an even number of roots. So if an imaginary root is there, its conjugate must also be there. So the conjugate of 4 plus I is 4 minus I. We have to take those imaginary roots and change them back into factors. So for example, I have x equals 4 plus I. I had to subtract 4 on both sides, then subtract I on both sides. For this one, I subtracted 4 on both sides, and I had to add I on both sides. Now we're going to take the 2 imaginary roots and multiply them together. X times x, x times negative 4, x times I. Negative 4 times x, negative 4 times negative 4, negative 4 times I. Negative I times x, negative I times negative 4, negative I times I. We know that I squared always equals negative 1. So this changes to be a positive 1. Now it's just a matter of combining our like terms. X squared is its only box with x squared. Negative 4x can combine with negative 4x to become negative 8x. Xi and negative xi combine to cancel out. 16 and 1 combine to be 17. And negative 4i and 4i combine to cancel. So I can take and multiply by the last factor that I haven't multiplied by yet. So I have x cubed minus 8x squared, 17x, 4x squared, negative 32x, and then 17 times 4, 68. So my final answer gives me x cubed minus 4x squared minus 15x plus 68. It's for that answer.